Okay, so now let's go ahead and do some of these computations that we need to do. So we've already done our forces. So let me change that view back. And I see that we're going to work with a value of 10, and my largest is that box right there. So I'm going to pick that box when I'm over here. Okay. I could also, if I want to, say equals the max of any of those ones. And then I've got it right there. So I've always got my maximum right there. I don't have to go looking. I don't have to try things out. That's my maximum. Because I found the maximum of all of those. So now when I'm looking at that, I know to look in this box for my sizing, because that's my largest force. So let's look at the wires. WWL, working load limit. Okay, so that is where this cable will break times 4, or maybe even times 10, depending on the company and what it's being used for. So that's not the strength of this. It's much stronger than this. But this is what you're going to use when you're calculating, because we really can't afford a mistake. There's health and safety issues if there's a mistake. So the working limit is listed right here. So I want to see if that working limit is larger. I'll put a question mark. Is it larger than my max load? So I can say if equals if this number 1 over is larger, that's shift over the period, and now I have to go find it, is larger than whatever is in that box. I'll go back. Then, which is a comma, type yes, so quotes, yes. Otherwise, which is a comma, type no, quotes, done. And look, they're all going to be larger. So let's see what these look like again when I view them as a formula. That's the syntax. Syntax means the way you write it. If the one next to it is bigger than whatever I found in D12 of this sheet, D12 of this sheet, then that's the comma, yes, else, no. And I'll make that a little bit bigger for you. So I'm going to turn my formulas back off, readjust the size, and I'm going to make these all nice and centered. And this is where I do my conditional, right? Format, conditional. If the cell contains the word yes, then make it green. And I see that they all do. So I want to find the smallest cable that will meet the requirements, and so I can go with a 1/2 inch cable. So I'm going to make those ones green. There's my answer. 1/2 inch cable with a working load limit of 5,400 pounds will be sufficient. But now it's got to hook into an eye bolt. So eye bolts also have maximum working loads at certain angles. So this can pull off at a weird angle, horizontal, straight up and down, the angle that it's pulling at. So let's see, ours are pulling at, say, about from axial 30 degrees. Okay, so if I went up from straight, this is what I would be doing right here. Okay, so I want 30 degrees right in these ones right here. So again, I can say equals if, let's copy these ones right down here. And I know I have to be checking my 30-degree column. So if with equals if this number is greater than my number over here, this, then back over to here, then yes, otherwise no. End parentheses. There we go. Now this is really interesting, and I didn't do it over here, and I really should have. See, those all kind of go and change. Those should all have been locked in with a $sign. And that way, when I copy it down, it'll always be going back to D12. So here we go. I have to lock that down with the $sign. So it always goes back to exactly that one. And again, I can say conditional if this box contains the word yes, then make it green. And so I can use a 1-inch eye bolt. And my last one is to take a concrete pad computation, and I'm going to just turn this on for you so you can see what I've done. From here, I can see that my concrete pad has the ability to stay in the ground is weight of concrete times 4. So weight of concrete times 4 has to be more than F1. Weight of the concrete times 4 is more than that. And I could change that to 12 because I went back to that other one. And so just like when I do anything, if it's on the top over here and I want to get it over here so that weight of concrete is by itself, it goes to the bottom. So it's whatever is in this box divided by 4. And the volume, this is pounds per cubic foot. So it's going to be whatever my weight is divided by that density. That gives me cubic feet. And so if I want a cube of concrete, it's going to be the cube root. And I've rounded up to 0.25. So that's what you're going to put in there. So let's go back to my view, and there it is. I need a 2.5 by 2.25 by 2.25 cube of concrete to put my eye bolt into. Okay, there we go. That is how we use a true shape drawing and the idea of vectors to find forces. The engineer did it for us a little bit, and then to plug them into a spreadsheet to find maximum forces, which is really useful so that we can say how big does that cable need to be, how big does the eye bolt need to be that's holding that cable, and how big does the concrete pad have to be that eye bolt is put into. There we go. There's the end of the Guywire problem.